Hey everybody, we are looking at the second half of derivative as rate of change. Yesterday we talked about how the derivative can be the rate at which any quantity is changing with any other, and then we specifically looked at the example of motion where if you have a position function and you take its derivative you get velocity. So as of right now we know that if you have a position function s of t and you take its derivative, that gives you the velocity of the function. So what we're going to check out today is what happens when you do a second derivative. In other words, you take the derivative of velocity. Now if you look at the rate of change of velocity, how the velocity of an object is changing over time, that gives us what we call acceleration. And in layman's terms, acceleration is a speeding up or a slowing down, right? Acceleration is what we can feel when a car speeds up and we kind of feel that pressure or we get thrown forward, right? That's our bodies reacting to acceleration. Gravity is an acceleration, right? It pulls, it speeds things up as they move towards the center of the earth. But acceleration, we have to remember too, and it will come up for us later, also involves direction, just like velocity. So an acceleration can be a change in speed as far as speeding up or slowing down, but it also can be a change in direction. And so that's going to come up for us as well. There's two components to acceleration. There's how fast you're going, and then there's also in what direction you're moving. So we'll take a look at that a little bit later today. Long story short, acceleration is the derivative of velocity because it's the rate at which velocity is changing, which makes it the second derivative of position. When you're given a motion problem, literally the first thing I do every time is take both of my derivatives. If they give you a position function, take the derivative and get an equation for velocity, take the derivative again and get an equation for acceleration. That way you just have them sitting there and you're ready to go for when they ask questions, because they kind of tend to go back and forth between what they're asking about. All right, okay, so we know we need the second derivative to get acceleration, but once we have it and we are interpreting it, one of the important things about it is going to be the sign on it. It's going to help us to describe the motion of the object. Now, with velocity, it was simple. Positive meant it was moving in the positive direction. Negative means it's moving in the negative direction. So positive is very simple to interpret. It's either moving up or to the right, period, end of story. And a negative is very simple to interpret. It's either moving down or left. End of story. With velocity, the only thing affecting the sign is the direction. When it comes to acceleration, that's not the case. There are two things affecting the sign. I made a little grid to help you to remember this. So there's two things that affect the sign. One is the direction that it's moving, right? If it's moving in a positive direction, I consider that a positive mark on the acceleration. If it's moving in the negative direction or to the left or down, I consider that a negative. Okay. Same thing with the speed aspect of acceleration. So this is its direction, this is its speeding up or slowing down. If it's speeding up, I consider that a positive. And if it's slowing down, I consider that a negative. Now, the reason I'm considering these positive or negative things or aspects of acceleration is that we have to put the two together to figure out what the sign of acceleration is. And if you think about them using this convention, that positive direction versus negative direction and speeding up being positive, slowing down being negative, then all you have to do to figure out the sign on acceleration is put the two signs together, just like we would do with multiplication of any two numbers. They come together in that way. So for example, if something is moving in the positive direction and also speeding up, that's two positive things coming together. It's going to create a positive acceleration. Okay? That's the easy one. Right? If you have a positive acceleration, it's speeding up in the positive direction. That's the one we like, right? But there's another way to get positive acceleration, and that's to put two negative things together. So if you have a positive acceleration, it could be that you're speeding up in the positive direction. It could also be that you're doing the two negative things. You could be slowing down in a negative direction. That will also give you a positive acceleration. Oh, crap. Okay. The other two then are going to give us our negative accelerations. So if you get a negative acceleration for an answer, they say, what's the acceleration at 5? And you get a negative number. That tells us one of two things. If it's moving in the positive direction, then it must be slowing down, because in order to have a negative acceleration, one of these two aspects has to be negative. If we know it has a positive direction, then then it has to be slowing down. And then just the opposite situation, if you have a negative acceleration and you know your object is moving in the negative direction, well, that means your negative is already taken care of. And in order to have a negative acceleration, you have to have one negative aspect. So if you already have negative direction, then you must be positive on the other aspect, which would be speeding up. Okay. So for me, this has always been a really easy way to remember it. Again, if all they ask you is what direction it's moving, that's a pretty simple question. When they get into saying describe the motion and acceleration is involved, that's when we start having to put them together. So we'll see questions are like, tell me when the object is speeding up or slowing down. And the mistake people make is they say, oh, well, speeding up is positive acceleration. Maybe. Or maybe it's negative acceleration in the positive direction. Okay. So I'm not even sure. I forgot my own question, and honestly, I don't remember. When was the object speeding up? That's what I said. Yes. When's the object speeding up? It could, the common mistake to make would be to say that's when the acceleration is positive. It could also be speeding up, but in the negative direction, which would give it a negative acceleration. So in order to tell when something is speeding up or slowing down, we can't just look at the acceleration. We also have to look at velocity, and we're going to make some sign charts to be able to do that. All right. So let's look at an example. That's the best way to do this. Pretty much just practice, 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 make some sign charts and do the analysis of the motion, and that's all we can do is practice these. There's not really any new calculus here. Okay, so let's take our derivatives. Like I said, first things first, if I want to analyze the motion of this particle, here is my position function, t cubed minus 6t squared. So if I take the derivative of that to get velocity, I'm going to have 3t squared minus 12t. And if I take the derivative of that to get acceleration, I'm going to have 6t minus 12. So now I have my equations. So if they came at us and they said, what's the velocity when time equals 5? Or what's the acceleration at time equals 10? We're just plugging in numbers. If overall what we want to do is describe the motion of this thing, or if they say where is it speeding up and slowing down, or where is it moving to, well, if they say where it's moving to the right or the left, all we have to look at is velocity. If they ask where it's speeding up or slowing down, then we're going to need to go to acceleration and look at them all. So I like to make 3 sign charts. The position one isn't all that important to us, but I like making sign charts. So, you know, that's just me. All right, so I'm going to make my position sign chart in the first row. So if you look at your function, t cubed minus 6t squared, that could be factored. You could take a t squared out, becomes t minus 6. So my position is going to have 2 zeros. I'm going to have a 0 position at 0, so it started at the origin, if you will, and then it got back to its regular 0 position at 6. So if we make a sign chart for this, between 0 and 6, if we pick any number between 0 and 6, oh, I choose 1. Right? If you pick any number between 0 and 6, well, you get negativeness. So the position is negative this whole way, and then after 6, if you put in a number like, oh, I don't know, 7, you get a positive number. So what we know about our object is that it starts at the origin, its position is negative up to 6 seconds, and then its position is positive again. So already we know something about the direction it's moving, right? If it goes from a 0 position to a negative position, it must have moved to the left. And then at 6, it was back to 0 again. So somewhere in here it turned around because it got back to 0. And then it must have continued to move to the right because its position goes to positive. Okay, so that's my position. Let's take a look at the velocity. Let's see if I can make this as obnoxious as possible in all these different colors. Okay, so if I look at my velocity, I'm going to factor out a 3t here. It's going to leave me with a t minus 4. So my velocity sign chart is going to have 2 zeros on it as well. 1 at 0 and 1 at 4. So let's check and see what's going on. If I choose a point in this first interval, let's say, oh, I don't know, 1, you get 3 times negative 3, so it's negative in here. I'm going to have a negative velocity on that whole first interval between 0 and 4. If I look after 4 and put in a number like, 0.05. I'm going to get 15 times 1. Everything over here is positive. So look what I've discovered about my particle, or whatever this is, my object. It starts off with a velocity of 0. It has negative velocity for the first 4 seconds, meaning it's moving to the left. And then at 4 seconds, it has positive velocity. So that's where we start moving to the right. And that is consistent with what we said down here with the position. It starts at 0, moves to the left for a while. That's why it has negative position. At 4, it turns around and starts moving to the right. It takes from 4 to 6 for it to get back to its original position, and then it keeps on trucking and moving to the right, and its position is positive. So we already, just with velocity and position, have a little bit of a story to tell about this object. Okay, let's add in our friend acceleration. So if I find the 0 of this acceleration, that's not going to be at 0. The only 0 of that is going to be at 2. So for acceleration, I have 2 segments to look at on my sign chart. Everything between 0 and 2, again, I'm going to put in something like a 1, and I get negative acceleration. And then after that, like it's something like 3 or 4 or 5, I'm going to have positive acceleration from there on. Once t passes 2, that's going to give you a positive acceleration every time. Okay. Now, again, in order to talk about what's happening with speeding up and slowing down, I can't just look at this. I need to look at acceleration and velocity together. And so the first thing we're going to do is break this into chunks. Okay, so I have this interval that goes from 0 to 2. So on the interval from 0 to 2, let's look at what's happening. I have negative velocity. So my object is moving left, right? It's got negative velocity. What is that? It's got negative velocity on that interval. All right, now it also has negative acceleration, right? So when I take moving left and I take my speeding up or slowing down and I put them together, I have negative acceleration. What's that tell you about what's happening here? If it's moving to the left, that's the negative. In order for the acceleration to come out negative, this motion, this aspect of the acceleration has to be positive. In other words, that's a speeding up. So on the interval from 1 to 2, because I have a negative velocity, it's moving left, and a negative acceleration, that means it must be speeding up, because I need a negative and a positive to come together to give me a negative. Okay. My next kind of change comes at 4. So on the interval from 2 to 4, again, my velocity is still negative, so it's still moving left. But now my acceleration is positive. So if it's moving left, that's a negative thing. If my acceleration came out positive, then it must have another negative aspect. Negative and a negative make a positive, so that means it must be slowing down in this interval. Okay. So I'm moving to the left, but I somehow managed to have a positive acceleration, so I must be slowing down. Negative and a negative come right back around to give me a positive. Okay. Over here, I've got both things positive. So on the interval from 4 on out, I have a positive velocity, which means we're moving to the right, but I also have a positive acceleration, which means I must have 2 positives coming together. So it must be speeding up again over here. So I have an object that speeds up here, then slows down, and then speeds up again. So again, for the first couple seconds, it's moving to the left and speeding up. Then it starts slowing down, but it's still moving to the left. So it speeds up and then slows down as it moves to the left. Now, right here at 4 is where it changes direction, right? In order to change direction, every good physicist knows that you have to stop for a brief moment, right? You're moving this way, and you go back to move this way. You have to have a kind of a stop. I always think of it like when you're on the swings and you go to, because you're on the swings all the time, and you get to the top and you're moving up right before you come back down. There's that brief, such a brief little like whoop pause where you kind of just feel yourself stop and then fall. So in order to change direction here, it had to stop. Notice we have a 0 velocity right here. So that's where it slowed down, hit 0 velocity, and then turned around and started speeding up back in this direction again, and it continues to speed up. So if they ask you, where's it speeding up, we would give 2 intervals. One interval, the acceleration is negative from 0 to 2, and one interval, the acceleration is positive. It is not lost on me. I'm sure you may have noticed this already, and people always ask me if they can use this shortcut, and yes, it works. Okay. You may notice that if the signs on velocity and acceleration are the same, that's speeding up. And if the signs are different, that's slowing down. That's true, and it works, and if you're a person who memorizes things, memorize away. I feel like in order to answer AP's questions, though, you have to have a deeper understanding of why the sign is the way it is. So if that helps you, if that gets you a quick answer to a question, great. But do make sure that you also understand the kind of concept behind it, that there's 2 aspects to acceleration. That's incredibly important to understand. Okay. Up next, I'm going to give you some of these problems and just have you do this analysis on them so that you can practice doing your derivatives, creating a sign chart, and doing it, describing the motion of an object. All right, see you soon.